Last time you met UNIX filters. UNIX filters work through a file a line at a time, and they process that file. Cat, for example, works through the file a line at a time. It takes each line of the file and puts it to standard output. So the cat command is really a non-filter because it shows everything that's in the file. WC is a filter which expects a file as input, and its output is the number of lines, characters, and words in the file. We also met head and tail. Head shows us the top of a file. Tail shows us the bottom of a file. And we met grep, which checks each line of a file for a specified substring. And if that substring is present, it puts that line to standard output. Those are all very nice, but what is much more interesting is when you combine the actions of UNIX filters. So you might be asking this question: can I make the output of one filter be the input of the next filter? And the answer to this is yes. And the mechanism that we use is something called a pipe. Now, if you look on your keyboard, above the enter or return key, you'll see the backslash. Okay, that's this key. However, if you hold down the shift on backslash, you'll see this character, a vertical bar. That is the pipe symbol in UNIX. So let's go ahead and do this. Suppose I might want to know, in the system dictionary, how many words contain 2 consecutive Z's. How many words contain 2 consecutive Z's? So here's what I'm going to do. I'm going to say grep. My internet connection has gone slow. Let's try that again. Grep. Okay, so I'm going to grep for 2 Z's. All right. The file /user/ oh, come on. Oh boy. Words. Okay, that's the dictionary file. Then I'm going to pipe that to WC, and I'm only interested in the number of lines because I know something about the system dictionary. Each word in the dictionary appears on its own line. So what I'm going to do is grep for double Z in this file. I'm going to pipe it to word count, and you invoke the line flag, and that's going to count the number of lines that contain a double Z. And when I hit enter, I will find out there are 688 of them. So you can see here that the output of this command, of the grep command, became the input of WC with the L flag. Now, suppose I might want to know, of all these words with double Z, how many also contain an O? How would I do that? Well, I can do something like this. I can say grep double Z /user/ share /dict words. Pipe this to grep O to look for an O. And then I want to know how many there are. I'm going to go WC -L. I know there are 160 of them. Now let's get even fancier. Instead of piping them to WC, I'd like to save them in a file, but I'd also like the line numbers that they reside upon. So, I do know this. If I use cat with the N option, what's that going to do? That's going to show the contents of the file with line numbers. So I could go like this. I can say cat N. Okay, now I'm going to take this and I'm going to pipe it to grep O. Oh, let's do double Z first, because that'll really cut things down. Then pipe it to grep O. Now I want to put it in a file. So what I'll do is I'll say Oz.txt. That sounds like a logical name. Hey, OZZ. And bam, let's open the Oz file. Hey, we can even do that with less. And you can see that the first time that pattern appears, an O and a double Z, is on line 358. Okay, and then you can see that there are others, and I'm using good old less, so I can go backwards and forwards, and this gives me a read-only view of the file. Okay, and I can see that there's a whole bunch of them. Let me see if capital G takes us to the end. Oh, it does. You know, a lot of the VI commands work in here, by the way. Schnozzle and schnozola. Hey, good old Yiddish words. So lots of interesting words appear, and I'm going to hit Q. Okay? So you can combine the action of UNIX filters by making the input of one, the output of the next. And here you can see I'm doing two things. I am showing all the items in the dictionary to grep ZZ, and he's going to drop out everything except for the lines that contain the ZZ. And then he is going to take that output and drop all the lines that don't contain little o. And then finally, all of that information is going to be redirected into the file ozz.txt. So we are able to combine the action of UNIX commands in many creative ways. You can begin to think about all the ways in which you can search for information in files. So these techniques can be very useful if you're doing forensic analysis on a computer. Now, I'm going to go ahead and introduce you to some more useful filters, and one of them I would say is sort. Sort is a very cool filter, an extremely useful filter. Sort sorts things. So to learn about sort, why don't we do something like this? I have something called jumble.txt, and I'm just going to put some numbers in here. 34, 56, 11, minus 6, 14, 55, 892, 191. So I'm just do the same thing yourself and just put a bunch of numbers in here. And 231 minus 777. Yeah, 777 minus 42. Okay, so I just made this file. All right, you can make a similar file. So now let's just type sort, okay? Because sort, like every other UNIX filter, by default expects standard input. But instead what we're going to do is we're going to use this file as our input, and it sorted it. And you're going to look at this and go, what the heck happened here? Because these do not appear to be in order. Oh, well, let's go in and look at sort's man page and learn something about it. Remember, the man is your friend. Okay. Oh, you can see here there is a flag or option for numeric sort. Okay, numeric sort. Yes, we want to sort as numbers. What it's doing is it's sorting things ASCII cographically. So let's go ahead and try sorting things, or maybe or alphabetically, something like that. So let's see what happens if I do sort -n. Oh, look at that. Okay, so if you want to sort numeric data, you sort it this way. Now, here's another interesting use of sort. I'm going to make a file called names.txt, and I'm going to put some names in here: Joe, Peter, John, Joseph. Oh, let's see, Joe again. All right. Okay, and yeah, it's pretty good. Malachi, and why don't we put in Nathan? Okay, so we got a list of names here. All right. Now there's a filter called UNIX, which is very good at eliminating duplicates, but there is a caveat. Let's go UNIX names.txt. All right. There's our file, but you'll notice there's still 2 Joes here. So we didn't get rid of in fact, there are 3 Joes here. We didn't get rid of that duplicate. UNIX will only check neighbors for duplicity. So if you wanted to get rid of all the duplicates in names.txt, what you might do is sort and then pipe this to UNIX. All right. And now what happens is the sorted names go to UNIX. And when UNIX sees 2 items in a row that are duplicates, it drops the duplicate items. So by sorting them first, all the duplicate items become neighbors, and now you get rid of the duplicates, and you have a list of names that is free of duplicates. Sort has some other features that are nice, like reverse. To reverse, just use the R flag. Here, we now have all the duplicates out, and we put them in reverse order, reverse alphabetical order. Is it case sensitive? Let's go in and find out. The best way you can do this is to actually go in here and let's have a little fun. Here's a nice VI trick if you've never done it before. Tilde on top of a character in command mode will justify it. Okay, so now we have a Joe with a capital and a Joe without a capital. Let's see what happens when we sort that. Okay, it appears that by default it ignores case. Now let's see what happens when I do this. Sort names.txt, pipe UNIX. You see, we're still UNIX is case sensitive. So sort sorts ASCII cographically, but not in a case sensitive way. It's sort of you can just think of it as being alphabetical. So sort sorts things alphabetically. So that's the sort command. The sort command sorts things in a file. Quite a useful little tool. Now, here's something that is kind of interesting. you can extract a line from a file. Watch me get line 50,000 out of the system dictionary. Here's what I'm going to do to even show you it is line 50,000. I'm going to go cat. Okay, now how am I going to do this? I'm going to pipe this to head 50,000. Now, how do I get the 50,000th line? That is the last line of this output. So all I have to do is tail 1. And there I am. The 50,000th line in the system dictionary is bow-legged. So what we've learned today is you can combine the actions of different filters to extract information from files. So we learned about pipes and how to use them to make UNIX filters work together to make things happen for you. In the next video, what I'll do is I'll talk about a couple of advanced commands, cutting and pasting. These can be quite useful and do some pretty interesting stuff.